All right, today we're going to look at our first section on proofs. We're going to look at how to prove that lines are parallel. Really, the majority of what we're going through today is we're just going to talk about some theorems, and then we'll just do kind of like some basic proofs, and then really, I think we only have one full proof that we're going to do at the very end, okay? All right, so first thing we're going to look at on the first page. The converse of a statement is when the hypothesis and conclusion are interchanged, which we've talked about this before. Remember we went through a whole section where we talked about converse, inverse, contrapositive. Okay. So converse is just when you switch your hypothesis and your conclusion. Okay, so the corresponding angles theorem says if two parallel lines are cut by a transversal, so this first part is our hypothesis, then what? The pairs of corresponding angles are congruent is your conclusion. So our corresponding angles converse says if two lines are cut by a transversal, so the corresponding angles are congruent. I'll kind of abbreviate a little bit. Then the lines are parallel. Now, we're going to go through each of these different converses, and then we'll just kind of look at some examples of how we would use those in a second, okay? All right, the alternate interior angle converse says if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So essentially, if we have a pair of angles and we know they're alternate interior angles, and it tells us that they're congruent, right, either marked with an arc or they're both 40 degrees, then we can say the two lines are parallel because of this statement. Yes? That's all we're saying here, okay? Essentially on each of these. Same thing with alternate exterior angles converse. It says if two lines are cut by a transversal, so the alternate exterior angles are what? What would those angles also have to be? They would also have to be congruent. Then we can say the two lines are parallel. Okay, and then same thing for our last one, consecutive interior angles. If two lines are cut by a transversal, so the consecutive interior angles are congruent, then the lines are parallel. Okay? So we're going to look at some examples of that down here at the bottom. It says, given the following information, determine which lines, if any, are parallel. State the theorem that justifies your answer. Okay? Now, what I'm going to do, like, it kind of gives you, we're going off of just this over here. Now, notice on example 1, it only wants angles 3 and angle 7. So what I'm going to do is I'm just going to redraw those two lines here. Doesn't have to be perfect, just kind of helps us so we can see just the ones we're talking about. So angle 3 is located here. Okay, so notice I took angle 3 from this corner, angle 7 from here, and I just kind of marked those over here. So we're going to determine if they're parallel. So can I determine here that lines A and B are parallel? Yes. By which theorem? What type of angles are those? Not vertical. Remember, vertical would be directly across from each other here. So I'm looking just at line A and line B. So I can ignore this line here, right? It's almost like that one doesn't exist. What type of angles are these? Alternate interior. Good. So all I have to say is alternate interior angles converse. We'll say A is parallel to B. So we can say A is parallel to B because of the alternate interior angles converse. Right, same thing here. We're going to draw our pair of lines. We'll label the ones given. So it asks for 9 and 11 here. So 9 was located here. 11 was located here. So again, we're kind of referring to A and B. So can I say that A is parallel to B? Yes, because these are what type of angles? Corresponding. So A is parallel to B by the corresponding angles theorem. Sorry, converse. So really here, we're just trying to identify the angles and then we know what converse we're using, okay? All right, example 3. We're looking at angle 2 and angle 16. So angle 2 is located here. Angle 16 is located here. So now we're referring to lines L and M. So can I say that L is parallel to M? Yes. By what converse? Alternate exterior. So alternate exterior angles converse says those two are parallel. The other nice thing about this is it's just giving us a reminder of how to name these angles, which we've been talking about for a few days. Okay? All right? Sorry, I wrote the wrong thing up here on this. Let's go fix this. That was my fault. I was going so quick I wasn't paying attention. Consecutive interior angles. What do we know about consecutive interior angles? None of y'all caught me on this. Are consecutive interior angles congruent or supplementary? Supplementary, yeah. Right, because remember, consecutive interior is the ones we're talking about right now, right? 5 and 12. Okay, 5 and 12 are located here. 6 and 11 would work. 7 and 10. Any of those would be consecutive interior, so same side, but not the same angle, right? So, I should, again, draw this because I've done it on all our other ones. So again, we're talking about angle 5 and angle 12. So can I say that angle 5 is supplementary with angle 12? Yes, right? By consecutive interior. So let me ask this. Am I talking about lines A and B or L and M?
Just
L and M right here. So we can say L is parallel to M by consecutive interior Okay. Not too bad. Yes? Questions on that part? Okay, let's look at the back. All right, the start of page 2 says determine if there is enough information to prove that A is parallel to B. If so, state the theorem you would use. Okay? So, on example 1, is there enough information for us to prove that those are parallel?
Yeah.
There is. What information will we have?
60 degrees and 120.
But what part of that would prove A is parallel to B? Well, they're not vertical angles. What type of angles are they? They form a what?
Line.
A line. So they're just a linear pair. But does that mean since these two form a linear pair that B has to be parallel? Is it not possible that A could be off a little bit from a parallel line to B? Yes, right? Because, listen, before we even talked about parallel lines, didn't we have lines that could look like this? Like, let's say it looked like that. Well, aren't these two still form 180 right here? Yeah, but this line and this line are not parallel, are they? Okay, so a linear pair doesn't tell us that two lines are parallel. Okay, so we know this is a linear pair. And we're going to say not enough information. Now, is it still possible those two could be parallel? Yes, but this just doesn't give us enough information to say that for sure. Okay? All right. What about example 2?
It's ultimate interior, correct? And there is enough information.
To what?
There is enough information and it's ultimate interior.
How would you know that?
Because it's all the other side of the line.
Let me ask you this one question. What do we know about this right here?
It's 108.
We for sure know it's going to be 108, right? Because we know all vertical angles, okay? Now do I have enough information?
Yeah.
Yes, because what do I know?
Consecutive interior.
I know that 108 plus 72 is equal to 180. So I can say these are parallel by what, Austin?
Consecutive interior.
Good. Consecutive interior angles converse. Okay. All right. Anybody have a thought on example 3?
There's not enough information.
Isn't it the same as last one?
Yeah, I mean, you could put
But it
40,
doesn't
you
equal to
could put
180.
49, like on the opposite side, and 120 on the opposite side of it, like vertical angles.
I think we're getting to the right track. So the other thing I would do is like, could I find this angle right here?
Yeah.
How? How could I find this angle right next to 121?
Minus 180 from it.
Okay, so what's 180 minus 121?
59.
Okay, now, what should I know about this angle and this angle? If they're parallel, they should be what, Caden? The same, right? Because what type of angles are these?
Acute.
Well, true. No,
Huh? Corresponding.
corresponding. And if two lines are parallel, corresponding angles should be congruent. Are these two angles congruent? No. Okay, so our corresponding angles are not congruent. So not parallel. Now, again, That's not the only way for you to figure that out, but that would be the quickest way to your answer.
But
Okay.
obviously you can look at 121 and 149.
Do what?
I mean, I just look at 121 and 49 and know does it equal to 180.
Well, sure. But like, you're going to have to give some kind of proof as to why.
Okay.
Okay. All right. It says find the value of x that makes the two lines parallel. So, are we just assuming then that these two lines are parallel?
No.
Yes, because we want to find the value of x that makes them parallel, so we can assume they are and then solve, right? So what type of angles are these two here? They are alternate exterior, and what do we know about alternate exterior angles? Are they congruent or supplementary? They are congruent. So how would I set this up to solve? Good. Yep, set them equal to each other. Okay, then all I have to do, move 5x over with 6x. So I get negative 5 is equal to x minus 20. And the only thing I would have left to do, add 20 to both sides. So my value for x here is 15. Okay. All right. Make sense? Okay, same thing on example 2. We want to find the value of x that makes the two lines parallel, so we can assume they are parallel. Turner, do you know the relationship between those two angles?
No.
What word do we use if they're on the same side?
Consecutive.
We do sometimes use corresponding, but corresponding means same spot. So say it again, Serenity. Consecutive what?
X.
Consecutive exterior. Good. So these two are both on the outside, so they have to be consecutive exterior. And what do we know about consecutive exterior?
You got them to equal
Add them to equal 180. Good. Okay, Turner, will you go and solve that for me?
You add 7x, 5x, and 5 and 19.
Okay, what's 7x plus 5x?
12x,
5 plus 19.
24.
Okay. All right, keep going.
And then subtract 24, 180.
Okay, we get 12x is equal to 156. Last step,
You got to divide 12x.
12x.
Or you divide 12
Good.
divided by 1.
X is 13.
X is equal to 13. Okay. All right. So far, do we feel like this is okay?
Oh, no.
What, Joss, you say that every time, and then rolling through it. All right, last part. It says prove, we want to prove the alternate interior angles converse, okay? So it gives us that angle 4 is congruent to angle 5, and we're trying to prove that A and B are parallel, okay? So what is our first reason that 4 is congruent to 5? It's given to us. Okay? Now, the next step they tell us is that angle 1 is congruent to 4. How do we know that angle 1 is congruent to 4?
Vertical.
Vertical angle theorem.
Are we using that diagram above it?
Yes.
P-H-E-O-R.
Okay, now, how did I go from, I had 4 is congruent to 5, 1 is congruent to 4. Now I know 1 is congruent to 5. How do I know that? Transitive property. Good. Now, 1 is congruent to 5, right? Remember when we look at transitive property, when two things are equal to the same thing? So both angle 1 and angle 5 were congruent to 4, so that's why I can say the two are congruent to each other. So now, I'm moving from 1 is congruent to 5, so this angle here, congruent to this one here. So I can say the two lines are parallel by what converse? What type of angles are those? Good. Corresponding angles. All right, today we're going to be in the book. So if you want to grab your book,